Well, my wife puts it in the bathroom and opens the cage door so that the thing can fly around the bathroom. Not if you need to use the toilet and the bird's on the toilet and he squeaks at you. Just not a bird person. Anyway, yesterday, I talked about this image in the lecture, but I didn't explain it completely. I gave a pretty big hint. Did anyone pick up on what that hint might be? Why is it that these little animals, these shrew, the harvest mouse, the mouse, why is it that they have so much higher basal metabolic rate compared to the elephant? Yeah, it's got to do with surface area and it's got to do with volume and cells for that matter. So the deal is these little creatures have little volume. So comparatively, they have a large surface area, which means that they dissipate heat much more rapidly than a larger organism would. So the elephant out here and the horse, they're going to stay warm longer because of that volume, because they've got a larger volume. It's always surface area to volume ratio. And so their ratio is going to be a smaller ratio, so they don't dissipate heat very well. Whereas the shrew and the harvest mouse, these guys are going to dissipate heat very quickly. So in order to compensate for that, they have to have a really high metabolism. Because in metabolism, one of the things that you lose is heat. So the more metabolism you're performing, the faster your metabolism is, the more heat you're going to lose. Yeah.
Wait, so they have less surface area?
They're going to, so if you look at, it's not surface area, it's not volume, it's the surface area to volume ratio. So their surface area to volume ratio is going to be high, meaning that they are going to more readily dissipate or lose heat. So to compensate for that, they have to have a high metabolism to generate more heat. That is that graphic. And then yesterday we talked about glucose metabolism or glucose regulation. Was that clear on that one? Okay. Yeah, I apologize for biologists everywhere. There's too many G words here. There's glycogen, there's glucose, there's glucagon. And keeping them all separated or straight is kind of hard. So, note cards might be good for that. Insulin is going to be it's a protein hormone. It's hydrophilic. That will become important as we go through some of the notes later on. Its job is to tell the cells that there is glucose in the bloodstream and it needs to be brought into the cell. And that glucose will then go right into cell respiration where ATP can be generated. Okay. Glucagon is going to be responsible for taking stores of glucose, which are called glycogen, another G word, and breaking those down. Those are the times where, it's right before lunch or dinner and you're hungry and your body is trying to do something about it. It's going to break that glycogen down because of glucagon. Glucagon gets released. That's the hormone. Glucagon will signal the cells, specifically the liver and the muscles, hey, let's break down glycogen. Let's turn it back into glucose. And then that will temporarily feed the cells until we can get some more food in our body. Where I left off yesterday was on where insulin goes, where insulin no longer works, and that's when you have diabetes mellitus. There's two forms of this, and it's just typically called diabetes. Mellitus refers to sweet urine. Because what is happening in people with diabetes is they are excreting excessive amounts of glucose in their urine. So one of the very simple tests that they can do to kind of rule out diabetes is to do a urinalysis. They'll have you pee into a cup, and they will check to see if there's glucose in that sample. If there is, then that's an indication that there's something wrong, and that's often cases it's diabetes is the problem. Diabetes is caused by either a lack of insulin or a decreased response to insulin. In either case, your body's cells can't take up enough glucose because they don't know that the glucose is out there in the bloodstream. And that starts causing your cells to starve because they're not getting the food that they need to produce ATP. That can also affect the kidneys, and when it affects the kidneys can't reabsorb it anymore. There's too much glucose in the urine, and so you can test the urine for sugar, and if you find it's elevated, that's a classic symptom of diabetes. There are two types of diabetes. Diabetes, one is autoimmune. Autoimmune means that your body's own immune system starts attacking itself, and there's all sorts of autoimmune diseases. Diabetes is just one of them. It attacks the cells that in the pancreas that are responsible for making insulin. So they're attacking those beta cells, and the beta cells make insulin. It usually happens early on in childhood, and you'll see people with meters. They've gotten pretty sophisticated now with the meters and pumps. It used to be back in the day you'd have to prick your finger to check your insulin levels to see if check your glucose levels to see if you had too much glucose in your bloodstream. And if you did, you'd take an injection of insulin. And you might have to do that 3, 4, or 5 times a day. I actually rode with a woman who has type 1 diabetes, and we would do these long rides. We were trying to do a century, which is a 100-mile bike ride, just to get there, in under 5 hours. And at one point, she had to stop and check her glucose, and then take some insulin because the ride was so long that she had to do something because she was fueling, she was eating while she's on the bike, but her body wasn't actually taking in the calories, so she had to take the insulin to get that to happen. And that was just part of her routine. Now they actually have pumps that can deliver the insulin directly to the body. And it monitors the insulin, and when the insulin levels get too low, it'll give an infusion of insulin. Owen, you had a question? Oh, that's a good question. Well, let's see. So we're talking insulin. You'd have more insulin. You take more glucose. I have a feeling it would be bad because it would probably make more glucose be stored than needed to be stored. And that could result in the body not having the food that it needed floating through the bloodstream.
Wouldn't it be able to use glycogen?
Yeah, so it could use glucagon, but if you're putting too much insulin in, that probably would not be very helpful. And something bad might happen before your body could react and get glucagon to change it back. Yeah. This is type 1. It happens usually early on. You usually find out when you're a kid if you have type 1 diabetes. The other type of diabetes is type 2. This occurs later in life, and it is not that your pancreas doesn't have insulin. It does have insulin. It makes this insulin. But they oftentimes call it insulin insensitivity. There's a failure of your target cells to respond to insulin in the normal fashion. Normally, insulin communicates that there's glucose outside, and that triggers a response of bringing glucose into the cell. People who have type 2 diabetes, the insulin isn't recognized by the cells. And if it's not recognized, then it doesn't know there's glucose out there, and it just continues to float around in the bloodstream. And again, same result, you get excretion of large amounts of glucose. Type 2 is more, tends to be more lifestyle, associated with excessive body weight, as well as a lack of exercise that can dramatically increase your risk of type 2 diabetes. And this is type 1, or is it type 2 only? I have to look if it's type 1 or type 2. You don't have to remember this, but there are currently, I just looked this up for something else, there are 37 million people in the United States with diabetes. And I'm not sure if that's the two combined or if that's type 2. Type 2 is much more prevalent, much more common than type 1 is. Usually appears after the age of 40, but it can appear in younger people. There is childhood diabetes as well, type 2 diabetes, in younger people who are really sedentary, terrible regulation of what they're eating, and very sedentary lifestyle, not really doing anything. It's definitely an issue that's become worse and worse. The reason I looked it up is because have you seen the movie Super Size Me, the documentary? Yeah. You may or may not have seen it, but it's where this guy Morgan Spurlock goes on a diet of nothing but McDonald's for 3 days, for 3 meals a day for 30 days, and he can only eat McDonald's, and he has to eat 3 square meals a day. And one of the things that they talked about in the video was, at that point, I think it was maybe 2010 when the movie came out, 13 years ago. It seems like it's too recent. Anyway, at that point, they quoted that 17 million people had diabetes at that point. And now I Googled it because I wanted to know what it was now in 2023. And in 23, it's now 37 million. So it's really a problem. It's a health concern. Yeah.
If someone lost the weight and started exercising, would it go away?
That's a great question, and that I am aware of. That's a great way to control it, but usually that insensitivity doesn't go completely away. You can be what's called pre-diabetic, where you're starting to show those symptoms, and the cells are starting to not work correctly, and that I think is reversible. But typically, once you get into the actual full-blown type 2, you do have to usually take it. There's pills to reduce the glucose by increasing insulin, but it's not something you can get rid of at that point. Let's see. Overnourishment can cause obesity, which results from excessive intake of foods, energy, and all that excessive food gets stored as fat. Obesity can contribute to things like type 2 diabetes, but it also contributes to things like cancer of the colon, breast cancer, heart attacks, and strokes. So obesity is also an issue. And there is some suggestion that, again, regulating appetite and your consumption is another homeostatic mechanism that goes haywire in some people. And the question is, how can we help people who are in that particular category? And there's definitely some suggestion that there's genetics involved too. There's genetics, and there's brain structures and brain chemistry that are affected negatively by this as well. And so there's hormones produced that are not produced in other people, and that can lead to really more consumption, more appetite than you would think is the norm, and more consumption as a result as well. Questions on any of that? Yeah, okay.
How would obesity contribute to getting breast cancer? I understand.
So one of the things that you're not in stats, are you? You are. Awesome. So have you talked about correlations? Okay, so correlations are not causation, right? So just because two things are correlated doesn't mean that they're necessarily one causes the other. So I don't think it says obesity contributes to. So I think what is happening in these cases is there are certain foods that people who are having problems with appetite and consumption are eating more frequently that are also known or at least suspected to contribute to cancer. So it's not a direct causation. It's more that they're correlated because they're eating something in their diet that, and like Spurlock, when he went on this diet, he was eating nothing but processed foods. And we know that processed foods are not the healthiest things to have in your diet. And I think that's really what's contributing to the cancer. It's not the obesity directly. Yeah, it's a good question. It was me. Any other questions? All right, that brings us to hormones, and we're not going to talk about hormones yet. That's going to be another project for another day. Today I want to talk about the project for I'm going to actually stop this.